Andrew Delamere from AWS. I'm joined here by Roberto Pellegrini and Miguel Blaso from Connect Reply and Storm Reply. So they work with us, they're one of our partners. And what we're going to talk about today is the various aspects of AWS IoT and how we can leverage it. Now, we've actually built quite a big platform over the last 4 years with various different facets. So you can start by getting one of your Nordic boards out the front there and connecting it with a piece of SDK, and then producing one thing that talks basic humidity or basic temperature. But then you can scale it up to big customers like iRobot, who have 17 million devices on one endpoint in America. And it all is pay-as-you-go. So what can you do with that? How does that work? And how can someone go from nothing to a large-scale business? So, as we said, we're going to be talking about 3 different aspects. I'm going to be talking about the basics and how to get a use case to work. Then we're going to talk about scaling to household devices. So devices like microwaves and cookers and how you connect them at scale. And then lastly, we're going to start talking about industrial application. We're just going to touch on that. We're going to talk about how that works. So within AWS, a little bit of a marketing slide. We split it into 3 different sections. So we've got device software. So that's SDKs, that's FreeRTOS, that's Yocto Linux and other things. And then we've got connectivity and control. So how do you get the data from the thing into the cloud so you can do something with it? And then we've got the analytics services that go, right, okay, so I've got my data in the cloud, and that's all right, well and good, but how do I then make it do something useful? Okay. So based upon that, we have a number of products. Perhaps a better photo. We have a number of products. So device software down here, we've got our SDKs. We've got AWS IoT Greengrass, which is our edge processing gateway software. We have AWS IoT Device Tester, which is a virtual testing, so you can actually test the software that you've got against the platform that you've built. And ExpressLink, which is a module developed with our hardware partners, that just completely takes any of the development away. You just solder it onto your piece of equipment, and it just works. Then on the other side of things, we've got IoT Core, we've got loads of device management. We'll get into that in a little bit and how that kind of works. And then up the top here, we've got some fancy stuff. We've got SiteWise, which looks after our industrial analytics, OEE. Then we've got analytics off the back of that, so we're looking with machine learning, that's statistical averages and other things. Events, which is real-time state machines, which can then take a Bayesian input and then work out a result or an outcome, and we might get into that a little bit. Then we've got TwinMaker, which is our digital twin service, quite new, launched last year. 3D renderings and 3D views of things like factories. So we've done some stuff with Coca-Cola, we've done some stuff with Caterpillar, where they actually render their factory, and you can actually see in real time the values of the machines operating in a graphical interface. And then we've got FleetWise. FleetWise is one of our newer services that catches CAN bus information from vehicles. So that could be parcel delivery trucks and all the way up to large-scale automotive with the likes of Volvo and co. Okay, but it's complicated. There's lots of things going on, lots of boxes being drawn, and where do you start with all of that? Okay, well, let's start with a use case. Smartwatches. Who's got a smartwatch? You got a smartwatch? Awesome. Yes, yes. A couple of other people. Smartwatches are interesting, right? Because smartwatches use a lot of machine learning to actually work out the Bayesianness of your biorhythms, and actually they have to produce a result for you. Am I feeling better today? Am I ready to train? Am I ready to do a run? Why do I feel so tired all the time? Well, we've all felt that. Am I moving? Gyro, accelerometer. Have I traveled since the last reading? So GPS input. Is the wearer alive? Yes, I'm alive. I've got some heart rate, but that splits down. Is the wearer breathing? SpO2 sensor. How much oxygen is in my bloodstream at any one point? So that's the green sensor in your watch if you didn't know what that did. Okay, so How do we actually action that? IoT Core is our main service. You can go from connecting one device for free all the way up to 17, 18 million devices on one endpoint. It allows you to connect the device. It allows you to manage the certificates. It allows you to actually manage applications off the back of it with integrations. And we've got a number of SDKs. So, identity, device gateway. Is it alive or is it dead? Message broker, MQTT 311. A rules engine, which does a fine-grained parsing of the rules using SQL. So you can actually go, for device equals n, what is the value of x over a period of time? So every time a new message comes in that fulfills that criteria, it will pick it out and go, this device has tripped a trigger point. But then we've got a registry. How many devices have I got? What software are they on? Where are they in the world? What are they doing? And then device advisor at the end here is a test capability for IoT devices. So you're rolling out a new one, you're rolling out a new version of a new one. You not need to know that it works before integrating it into your fleet. Then we've got a whole bunch of SDKs. Part of this is what we're going to show in a quick demo, with a quick kind of overview with our watch thing. We've got various different SDKs going on from mobile platform, all in common languages. So we're trying to promote code flexibility. You can use Parho as well and Eclipse. And we're also promoting, security, end-to-end cloud security as well. But you can actually connect to IoT Core without a certificate. We have a custom authorizer service as well. Okay, so ingesting data with device SDKs. So we know that our generic smartwatch can connect to our mobile phone, which is here. It connects via Bluetooth PAN, and it has a sport and fitness profile with Bluetooth. We use a device SDK in the software application on the phone to pull the data out of the watch and then push it over the mobile phone network to IoT Core. Once it's in IoT Core, all the messages come in on their various topics. We then need to have a rule which says, well, okay, what do you want to do with this? You just want to sit there, or do you want to actually process it in some way? We can actually validate the observed states based upon a trigger point. Temperature is over 40 degrees. Temperature is under 5 degrees. Person has just registered a massive G-shock. These sorts of things. So we can put it in DynamoDB. We can list them all out. We can put them in an S3 bucket in files. Okay, that sounds like a reasonable idea to start with, but there is more to it than that. So rules are useful. Rules allow us to marshal data around from the IoT Core system to many different products in the AWS ecosystem. So we've got our smartwatches sending us this data via the SDK. And what we can then do is we can validate the topic with a select statement. And then we can then elect to do other things with it. So in this case, I'm retopicing it, just pulling out the temperature. So I'm looking at a statistical average. But we can do loads of things. We've got a where clause. We've got embedded Lambda that goes into that. We can send it to things like DynamoDB, time stream, Lambda, SQS, step functions. There's loads of things. So, all right, so we're going to send it to SNS, send a symbol of that. We're going to send it to IT analytics, into machine learning to process a pipeline of data. Or go into QuickSight. We can send it to a Lambda, or the Lambda can process the message queue, send it to a step function that's observing various different states, and then send it to SNS to have a more complicated error. We can send it to an EC2 via S3. We can get Splunk to read all that data and go, whoa, there's loads going on. We can send it to an S3 bucket on its own and leave it there, and then have a quick look at it with QuickSight later on. Historical data, not important right now, but what's my statistical average? We can send it to Kinesis, which will buffer it, and then we can then elect to preen the data as it comes in. Then we want to send it to our inference, elastic inference. Then we might want to put it into DynamoDB, comb it with a Lambda, send it with machine learning for a more defined, simpler data set. So that's loads of things we can do just without any coding. Okay? And that's what's important here. Send the message in, use the rules, send it back out again. So, ingesting data. So, as we saw from there, our mobile phone pulls it in. with MQTT, we put it on a topic. The rule reacts to the topic, sends it to an S3 bucket and DynamoDB, because we want to know what's happening right now, and we also need historical data for training machine learning models. Okay, so we've got hot side and cold side in effect. The Lambda comes off the bucket, and it looks through the bucket for data that it's interested in, that suits the median, and it goes to an elastic inference. There is a bigger piece of flow here, which I've kind of cunningly overlooked. All right, and that is basically, in this S3 bucket, you do need to actually pull enough data in and analyze enough data, wrangle enough data to be able to do a machine learning model in the first place, to train a model to actually do this. But once you've trained the model and you've got a model, you can then use the elastic inference here to then validate that. And then we then add that state that the elastic inference tells us back to DynamoDB. A Lambda then combs it, and we can then actually send it back to the device with a IoT device shadow. Bam. So, device shadow, what's that? So, device shadow allows us to talk back to the device in the field. Now, generally, IoT or MQTT in itself is a telemetry protocol. It's from device to the cloud. But we've added a whole bunch of stuff into the SDK that allows us to actually allows us the APIs to query back to the device and send state back. And that's with the device subscribing to more custom topics. And then we send the detail to the custom topics, and when it subscribes to them again, it goes, oh, there's a change. I need to do something with that. And it changes. So we can get things like fridge freezers and cookers changing state based upon reading our topic. Now, let's go to the machine learning bit before we go back. So what are we trying to actually do? So IoT on its own is just a data ingress. It needs other things to work, because you don't just ingress data for the hell of it. You need to have an application. And in our smartwatch scenario, what we actually need to know is the person sleeping? Yeah, interesting topic. Okay, so we're using standard regression as a machine learning to work out where the high and low and the peaks are. And then what we're going to do is we're going to bring heart rate, breathing, and movement into a sit state, and then we're going to do lasso regression to actually work out what the states are. So we've got our predictors, and we need to do our predictors on each one of these as separate pieces of data. And then what we then need to do is bring them together. Okay, so what we then have is we have a histogram in data of various different states of change in a sleep pattern. Okay, so lasso regression to work this out. So what we're looking at is change of peaks across the three data sets. So what have we figured out that one? We figured out there that there's a sleeping state. We then need to give it a prediction score of what we think is going on with the user's smartwatch. Looks like it's light sleep. And then we've got a dip of heart rate, we've got a dip of breathing cycle, and then we've got no movement. Looks like they're in a deep sleep state. All right? And we keep going through the night, working out what's gone on. Oh, they've got up and gone to the bathroom. There you go. So then they're going back to bed again, and then they're going light, dark, and then we keep going on. We get REM states in the morning. So there's a different change again where there's actually slight movement in the hands and in the eyes, and that actually registers because gyros are really quite sensitive. And then we go back to light sleep again, a bit more REM, and then we need to work out when did they get up. Okay, so the graph then changes once again, and we see, okay, wow. Let's work out if they're actually awake now. The heart rate rises, the movement becomes more active and more pronounced, and it's there for longer. So we're actually watching out. So we've taken all of that data from IoT, from the smartwatch, and then we've predicted it with the machine learning. So we then need to send that result back to the watch. So our elastic inference, our Lambda queries it and says, have you got a result out of the data set you just got given? It then updates the DynamoDB to say what your sleep score was. It then sends a message to the Shadow API, which then communicates back to the device via IoT Core to say, this is your new sleep score. There it is. And there you go. So IoT doesn't work in isolation. You need the hardware, you need the physical thing. You also need all of the pieces for machine learning. You need the pieces for wrangling the data. And you need experts that can do that. If you've got experts in your business that do that, fantastic. And there are a lot of smart people out there. But I brought these guys here today because sometimes you need a partner. And I'd like to get these guys up on the stage now to have a chat. There we go.
Thank you, Andrew. Is this mic okay? Can you hear me okay? Or
Can you
I'll
hear
use
him?
this one? This is maybe better, right?
Yeah.
Yeah. So, thanks, Andrew. Good afternoon. My name is Roberto Pellegrini. I'm a business unit manager at Connect Reply, and in the next 10 minutes, I will be sharing a bit about our experience as system integrator of connected products, specifically for the consumer industry. And then I'll move on to Miguel, who will tell you something about industrial IoT applications. Just a quick mention about Reply Group is an ICT consultancy and system integration group with a global presence, about 1.5 billion in revenues and 11,000 people working as technologists and even as designers. We more and more help companies perform a digital transformation where IoT is actually an important part. And we've been for years an AWS premier system integrated partner. IoT is one of our areas of expertise, actually, both in consumer and in industrial, as recognized also by independent market analysts. But I want to move a bit on to the business case of connected products, especially in consumer. So why is it relevant to build a connected product in consumer? And we have lots of big brands and consumer product makers we've been helping create a connected product strategy. Why is this relevant from a business point of view? Well, you can imagine, as you know, that consumer products typically have a sell and forget business model. So as a maker of the product, I never know who is my client who's actually using it because I'm disintermediated. I don't even know how the product is really utilized. So one of the most important goals of a connected product strategy is get to know who your customer is and get to know how the product is utilized. Getting to know how the product is utilized by data collection is both a feedback for redesigning the product, getting the insight, oh, well, the users are actually using this functionality or not. But adding also a dimension that I will cover in a second about embedded AI. Embedded AI is just a way to enhance now the type of information you can get from the product. This becomes really a life cycle problem, is how can I make the product evolve even over time to give more value to the end user? And how can I manage that? How can I manage that over time? Plus, because of resource constraints, most of the products might even have very limited human-machine interfaces. So also the digital extension of the physical product that we do via companion apps is a further enhancement for the user to integrate with the product and to get more data about the product. It's typically, a complicated journey, obviously, for a product maker to go through this, and this is why we try to help. You start needing to have an end-to-end system thinking, electronics R&Ds, and maybe do some initial proof of concept, but then you need to scale, and it's very complicated. And you start thinking about a software life cycle for a physical product, which is not, maybe a familiar concept, if you like, for product makers. So with over 10 years, we've been working with end-to-end system solutions. We've come to create what we call an accelerator. It's essentially a template that leverages AWS technologies, but it packages them, it composes them in what is really a complete end-to-end system for anybody who wants to have a traditional product connected and build the complete system solution that allows data to flow through, get to the product, and from the product to the consuming applications like the mobile apps, so the touch points for the end users, or even the enterprise business processes like e-commerce, for example. And this is a template. It's not a proprietary solution. Actually, we normally build, operate, and then transfer it to our clients for them also to become versant and internalize this kind of competence. And it's packaged with data structures, microservices, APIs, and abstraction layers, which address essentially 99% of the use cases you have with consumer connected products. So there's a big acceleration factor for an initiative. I've touched about AI, embedded AI, which is something we've been working a lot over the last 3 years as a key ingredient of a connected product strategy. When we talk about embedded here, we mean really embedded in consumer. You know, these are not Linux-based products. These are products based on MCUs, anywhere from Cortex M0 to M4, with very resource-constrained architectures, and therefore the expertise we try to bring is, well, in the first place, obviously, the data scientist end of the game is understanding the problem and devising the algorithms. But then it's about the firmware development expertise of compressing them and making them very efficient to run on very low power and very resource-constrained devices. But the important concept you see here on the right is actually what happens. It's not enough to just have an embedded ML algorithm or an AI done once. As Andrew was also saying, it's very important to manage its life cycle. So have a system like we develop that allows the model to be continuously enriched and enhanced in the field at 2 levels, whether the model is general, so it's actually applicable to all the users, or whether the model is actually personalized, and this means that your personal model running on your device will be actually optimized based on your data. Let me show you here a case of one of the industries we work with, which is micromobility. What you see on the left is a set of algorithms we developed for accident management and crash detection. In this case, it's applied to a bike. So this is now, I'll start this animation, is running on an ARM Cortex M4 on the bike, and it's a suite of algorithms we combine in order to detect whether there is a crash, for example. But here I'm showing you a specific case on how the algorithm has been trained to recognize another type of state, which is sort of a false positive, and it's now we are making the bike crash alone without the biker. And the 2 algorithms live, you're going to be seeing that now. The bike is going to be pushed with the other algorithm live. You see those are the features that the 2 algorithms combined are detecting. They're now detecting a state in real time whereby there is a crash, but the user is not on the bike. Therefore, for example, at this point, the system will not send a potential accident crash notification to the end user via the platform. So finally, regarding the ways you have connectivity, that was a case where you have cellular connectivity. When we work with other appliance industries, you normally would have Wi-Fi to implement a proper MQTT telemetry, which is the best way of doing that. But unfortunately, in some cases, you have very restrained devices that might only be based on BLE. So how to do something similar having BLE? Well, again, the Amazon suite comes with a nice facilitator here, which is in the Amazon FreeRTOS, there's a possibility to build effectively a channel which is MQTT over BLE by using an intermediate mobile app as a proxy. So due to now restrictions of time we have here, anybody who's interested about that, we can reach out ourselves here at the end of the show and we can tell you something more about that. Just mentioning a couple of real cases with brands we're helping develop very innovative consumer products. Connected initiatives, and this is the case of My Views, which is a brand of the British American Tobacco Group. So here we have a vapor which has been enabled with connectivity, and there's a very sophisticated companion app that's been built in order to enhance the way in which the user is actually interacting with the product and how, in a secure and anonymized ways, data of usage of the product is actually channeled. What you see in the scheme is really the logical partitioning of what happens in the background, and in the back of the scene, this is actually the IoT platform that's been put together, which is, as you recognize in its stages, is really about channeling data generated from the product to the consuming applications, which are the mobile app on one side, but also the enterprise applications like the e-commerce, and how the data are routed through by using components from the AWS suite in order to route them, characterize them, process them, and store them appropriately. One last case I can mention many such integration projects we have with home appliance vendors. This is another interesting case. Again, this is about the variety of and families of products and variants that these makers have. And again, with a system solution we built for them around AWS, the key concept here was to standardize the way in which each different control electronics of a variety of products like ovens, refrigerators, wine cellars, dishwashers, are in fact standardized in order to have a consistent way of representing such data to what is called the digital twin. And therefore, at the end of the day, for the user experience, it's a normalized brand experience. With that, I will leave the stage to my colleague Miguel, who will tell you about industrial IoT applications.
Oh. Might want to get you. Nope, you give him that one. There you go. Just take that one. We can swap.
That's right. I tested that.
So you've turned that one off now.
Thank you, Roberto. Oh. Okay, yeah, thank you. Yeah, so my name is Miguel Blasco. I come from a background in software engineering and platform engineering over about the last 25 years. And as they said, I'm going to talk to you a little bit about some of the offerings that we have around industrial IoT. Storm Reply is a company that partners and is dedicated to working with AWS. So although I come from a background of lots of different cloud providers, we have sort of come together, myself, the partner I work with, we've come together to work specifically with AWS. We found it the most stable and the most feature-rich cloud platform to work with over the last 10 years. And it's only growing quicker than any other one at the moment as well. So we're very proud to be here with AWS today. Thank you. Roberto spoke a little bit about smart products there. So he took you through a little bit of the journey around smart products. At Reply, given the size of the company we do a lot more than just smart products. We work with smart city, connected vehicles, IoT for energy, and industrial IoT, which is what I'll talk a little bit about now. I'm going to go in and talk a bit about something called AMP, which is our asset monitoring and predictive solution. So the solution we've come up with, and I'll talk about the architecture in a second, is a solution that integrates the hardware that goes out to the factory or to the plant, wherever it's going to be used, with the AWS backend. So it's a fully integrated solution that we provide to people. It allows operators, it allows customers to get real-time information about how their equipment is performing at any given time. It allows us to actually do processing at the edge as well. So we can do all sorts of processing. We can do different levels of processing at the edge as well. And we can come on to that in a little bit when you see the architecture. And it allows us to monitor and alert with no connectivity, because obviously one of the challenges, and I'm sure Andrew will attest to this, that AWS gets asked for is they want to make sure that any equipment they have or anything that's running at the edge can work without connectivity if needed. So we built that in as well. And we have also got pre-built anomaly detection and dashboards that are available. So because we've been rolling this out to different customers, the knowledge we have around the information that they want and how they want to build dashboards is something that we can often reuse, and we can actually accelerate customers with as well. But speaking specifically about the hardware, since this is a hardware event rather than a software and platform event, the hardware we've got is helping customers move away from proprietary ecosystems, be they Siemens, be they Honeywell. So we're helping people move away from those. And we're also introducing commodity compute. So the devices you see are here on the left-hand side. They're typical devices that we roll out to various customers. And we're introducing this commodity compute, which helps with licensing costs. We're using a lot of open source technologies. We're using AWS, and the licensing costs get reduced as a result of that. Also, if you look at the size of them, we can go quite small. We can reduce power. We can reduce space requirements, if that's an issue for anybody. And it simplifies IT support. So the actual effort to support this is a lot easier nowadays, because a lot more people in the market have the skills required to support the type of software and operating system that we run on this. And finally, and it's not in the use case that I'm talking about now, we have the ability to run AI, ML at the edge. We're not seeing a lot of take up on that on some of the industrial IoT at this stage, but for some of the things we're doing with computer vision, if somebody walks onto the shop floor and you need to make sure they're wearing the right PPE, that type of thing, Those types of use cases, we're actually seeing we're starting to apply inference at the edge. At the back end of this, we've got some dashboards. So this is just an example of one of the dashboards, specifically from the use case we're talking about in a second. And this is developed using Grafana. And we also, because all the data, as Andrew showed you, is all back in the cloud, we can actually do anything we want with the data. So we can build responsive websites, we can present it in any way that we want. This is just an example of a dashboard that we built for a customer that was selling smart products. And they wanted to offer this dashboard to their customers. So this is a B2B type scenario. But as I said, we can build anything off the back of this. It's just data in a database, and we can do whatever modern development is required to present that in an interesting way. So this is a view of the architecture that we've been working with. So this is what I wanted to talk a little bit about. So this is a customer that's got some Siemens PLCs, and we've built in the orange box an edge device. So this is one of those orange because it's one of those little orange servers you saw on the previous slide. And the green box here is AWS. So it's basically three major components to this. The Siemens PLC, we pull data off that, goes through the edge device, and then we move it over to AWS to do some analysis. We've got a few components here within each of these boxes. So the Siemens PLC itself, this is where we get the OPC UA data. So we pull that off. And unfortunately, with this customer, the way they'd actually structured that, they had created additional levels of tags. So there were nested tags within the data structure they had. So we couldn't pipe it straight into site-wise connector, which is typically what you can do. So if it's structured, the Siemens PLC itself will actually structure it normally, and you could actually pump it straight into Siemens, straight into site-wise. But what we had to do, we had to introduce another component, and because we had that commodity compute on the edge, we could just install Ignition Edge, and we could actually do that translation of that data at that point there. We then push it through site-wise, and at this point here, this is one of the key parts of this overall architecture. This is where we need to think about what the structure of the data is. Getting that data structure correct is the most important part of any one of these projects. So structuring it and getting the way that you want to structure your equipment, your assets, and how you want to model that is the challenge. So pulling data off a PLC is easy. Moving data to AWS is easy. Structuring the data, that's the thinking part of all of this.
Yep.
So once we've done that in site-wise edge, it goes through the Greengrass core, which is part of the IoT core that Andrew was talking about. And then we do a little bit more processing here with AWS site-wise in AWS. So we do a little more processing at that point there. And once we've done that, we have the ability to present it to Grafana. And Grafana is just an industry standard tool to create dashboards. You can create gauges, you can create graphs, you can create all sorts of information to present the data that's coming through in a sensible way. What we also have the opportunity to do is we have the opportunity to use QuickSight, which is one of the other tools Andrew spoke about. This is a reporting tool down here. Now, AWS has done something very clever with its S3, with its object storage. And what they've done is they've created something called Athena, which allows you to just run SQL queries against data that's being stored. It's a very, very powerful tool. So with that, we're able to use tools like QuickSight just to run reports. One of the reports we built for our customer was sort of like a 24-hour view. So what had been happening over the last 24 hours. They wanted to have that report created daily, and that was very easy to do. If you don't use QuickSight, if you're a customer that uses Power BI, you could just replace this. It'd be in a different cloud, but there'd be a Power BI box there as well. Sorry. So there's customers use lots of different tools. So this type of architecture gives that ability to have a easily integratable solution. And finally, one of the things that we're also doing is we're using a tool called SSM. And that is a tool for managing the devices remotely. So we can connect to that server, which is in that orange box. We can patch it, we can update it, we can connect to it and do all the things that you need to do from an operational point of view. So that sort of brings us to the end of our talk. We want to give you a few minutes for questions. But before we finish, I just want to say at Reply, we've spoken a little bit about smart products and industrial OT. If we'd had another hour, we could have talked about the other ones as well. But
This is a much longer conversation, which we've compressed a lot, right?
exactly. But what we do want to offer you the opportunity to do between AWS and Reply, we want to offer you the opportunity for like the first 10 customers to come and ask us for a consulting session. We'll do that with you so that we can have those deeper conversations.
Yeah, if you've got a cool idea and you need some support, give us a shout.
So yeah, if you take a photo, emails are there. You can contact us on those emails. But yeah, I just wanted to give you 5 minutes to ask questions if there were any in there.
Any questions? There's one. This gentleman here.
Yes.
We have a mic lady. Thank you.
Hi.
Hey.
Question to the AWS guy.
Hey.
To build application using your cloud-based services, do we need to use your SDK on the device itself?
You don't need to. It depends what you're sending, though. The SDK makes it easier, and it also makes it easier to do TLS authentication. But you can use Paho and Eclipse on the device, or you can use native libraries.
Okay, but it will always be in MQTT format, basically, right?
Or HTTPS. You can
HTTPS.
send it in HTTPS as well.
Okay. All right.
Have you got legacy devices?
We do, yeah.
Yeah. Are they
So,
unencrypted generally?
some encrypted, some unencrypted. So
Yeah.
we do TLS, SSL, or with TLS or without TLS. Yeah.
We also have an unencrypted service for devices which are legacy that can't do encryption or they're just too small, called Custom Authorizer. And what that does is it allows you, it's basically a gateway redirect which is fronted by a Lambda. It works out what the device is and why it's there in its class.
Sure.
It authenticates it based upon username and password, for example, or client ID and password, and then allows it to send a message to a very specific topic which is incredibly locked down.
Mm-hmm.
So all of the devices send to one topic, so you can still take on unencrypted devices in
Okay.
that way.
All right. Thank you.
Any other questions? One there, right at the back. He's got an impressive beard. I like that. It's good.
Thank you. This is more a question maybe for consumer electronics, so maybe Roberto, around the value of IoT and connecting devices that were previously only connected. Is it a value to the customer or is it a value to the business? Because I know there are times when customers have a device and through a lack of firmware update or the cloud services going down, their once standard object that would have cooked their food or brushed their teeth is no longer able to provide that service. So do you see it as more of a value add to the customer or to the organization? From your experience, of course.
It has to be, you're right, it has to be value for both. And this is where doing it right, so doing the system right in order for giving a valuable, so a good user experience to the end users is key. Otherwise, you lose clients instead of getting them on board. For some products, it is actually quite complicated. For others, the value that the users perceive from the connected product is quite immediately visible. And again, you got to do it right. Imagine what I was showing here regarding micromobility, for example. That's related to safety, right? So you know now you have something that takes care about you, could alert, for example, your contacts, for example, if you have an accident, something like that. So it's important to do it right, of course, and this is our job and the job of the product maker. It's a very tangible, visible value for end users. Other values for end users would be if you intelligently get to understand what they're looking for in the product. By the way they use it, you could actually infer that there's something they're looking from the product. Some products even lend themselves even further because maybe they are based on consumables, and therefore the variety of consumables you add to that can add value. For example, we work with coffee machine makers, a number of brands I cannot mention, but the strategy there is as an end user of a machine, the machine gets from our systems automatic settings which are different depending on the type of coffee. We let you try one coffee, you taste it, you via the app say, was it good, was it bitter, the cream was okay. And based on this feedback, our system automatically, through a knowledge base, reconfigures the machine to tune it itself for a better coffee. Then you try it again and it's better. So this is completely visible to the user. Again, if you do it wrong, it's a problem. But if you do it right over time, that user gets more engaged with the brand. And then there comes the value for the brand also.
You could also argue that even if the user has got no part in the product's lifespan just by using it, if you're looking at the batch, the manufacturing date, the subcontractor of manufacture, and you're comparing states of operation of the device against when it was made, who it was made by as a subcontractor, which board it was, which rev of the board, all of these things come together to make you understand better about your manufacturing process and how to enhance it, or which subcontractor to use, who's better in batches and for warranty and other things, right?
If we may have a suggestion for the hardware decision makers here of yourselves, is don't compromise on hardware security. So one of the big problems we see with some of our clients, they come with hardware designs with no thinking about security. And when we say security is, for example, the choice of MCUs with some forms of hardware security modules, or even to the point that we always suggest is to even add a hardware security module. That would give you, a raft of opportunities to store securely certificates. So it's about making sure that the authentication of the product is absolutely, secure, and anything you do that also would comprise encryption. Not to mention the fact that when you do firmware upgrades of the product, security becomes obviously a key feature to avoid, tampering.
She's looking at us over there.
All right, thank you, Roberto. Thank you all for coming. Really appreciate your time today. If you do want to contact us, our details are here. But have a good rest of the day. Enjoy the conference.
Absolutely.